Hey class, so this is day number 2 of our STAR English testing, and it's going to be asynchronous as well. We're going to learn our second gas law, and it's just as easy as the first one. This law is going to be called Charles' law. So when you log into Canvas today, you'll skim down, assuming you've completed Boyle's law, and click on Charles' law. This will be April 8th. This doesn't apply to A-Day. The first part is going to be the video that shows you exactly how to do it. I'm going to show you a second example in just a moment. Charles' Law practice check. That's going to be the practice that you need to complete before you can do the independent practice, which is what will go in the grade book. That'll be the grade for this particular module. So, what is Charles' Law? Well, when you open up this practice check, it gives you an idea. It says, look, the formula for this is V1 over T1 equals V2 over T2. So your initial volume divided by your initial temperature has to equal your final volume divided by your final temperature. So in this case, if Charles' Law, pressure is constant. There is no change in pressure. You won't have to use pressure. You won't have to have any type of unit for pressure. If they give you pressure in the question, it's just fluff. It's just there to add to the question. It won't be used to calculate the final answer. One thing that you will have to do, though, since temperature is a factor, all of our temperatures must be in Kelvin. Celsius and Fahrenheit will not work. Everything must be in Kelvin, and Kelvin is easy to convert when you have Celsius because you simply take your degrees Celsius and add 273 to it to get Kelvin. Fahrenheit, we're not going to talk about that yet right now, so don't worry about Fahrenheit. Let's look at a practice problem as to what Charles' Law would look like. I don't know, what's a good one in here? Some of these are going to ask for work, and some of these are going to ask for the answers. This would be a good one to do. All right. It says, on hot days, you may have noticed that potato chip bags seem to inflate, even though they have not been opened. If I have a 250 milliliter bag at a temperature of 19 degrees Celsius, and I leave it in my car, which has a temperature of 60 degrees Celsius, what will that new volume be once the volume has changed? All right, so let's go to our whiteboard. First thing first, write that formula down. V1 over T1 has to equal V2 over T2. And pressure is constant. Pressure will not change in these problems. That's not an N. All right. Let's find out what we're solving for. It gives us the initial volume of the bag, and it gives us an initial temperature, and then it changes to this temperature, which will be the final temperature, and it wants to know the new volume. So we're solving for V2. So question mark V2. All right, our initial volume is 250 milliliters. Now, when it comes to units for volume, just solve it for whatever unit it gives you. So in this case, we're going to leave it at milliliters. 250 milliliters over, what was that initial pressure or initial temperature? 19 degrees Celsius. That ain't going to work. Sorry. Alarm's going off. That's not going to work. we have to turn that 19 degrees into Kelvin. So 19 plus 273. And we add those, we get 292. Now we can put that into our problem. So 292 K. And then this is what we're solving for. And our final temperature is 60 degrees Celsius, which won't work either. So 60 plus 273 gives us 333. So 333 K. And that's a 9. It kind of looks messed up. There we go. And now we have a proportion. What math technique do we know that we solve proportions with? Cross multiply and then divide. So we're going to take 333 times 250 and then divide that by 292, which gives us 285.1027. Let's go back to our quiz and see what it tells us. 285.10. So we're not going to keep these. And then remember, that's milliliters. Because we're just keeping milliliters. We're not changing anything. So since that's milliliters, we're going to leave our final answer in milliliters, which in this case would be right there. Don't get distracted by this liters. Not right. 285.10 milliliters. And that's how you do it. If you want to set it up, use that example that I give you in the instructions. Blank blank equals blank blank. And then solve for your final answer by cross multiplying. Easy as that. If you have any questions, let me know. Otherwise, make sure to watch the video, then complete the practice check and complete the independent practice, and you will be done with the second law. Moving on to the next. I will talk to you next time I see you. I hope you have a good day.